All right, the good news about section 9.9. Just like section 9.8, there's really nothing new. Really nothing new to learn. It's more just a culmination of the stuff we've done up to this point. So we have a tennis ball is tossed upward and its heights at various times are recorded in the table below. Determine a quadratic model, f of t, where f is the height at t seconds, using the vertex form of a quadratic function. All right, so this is exactly what we did back in section 9.8. What was the vertex form of a quadratic function? What kind of equation am I looking at? A parentheses t minus h squared plus k. Excellent. That's called the vertex form. It's called vertex form because h and k right away tell us the vertex. Okay, how do we use that equation together with this data? What do we look for? We look at the data and we look for a point that looks like the vertex. Looking at that data, which point looks like it's the vertex? The 2.7. Why do you think that one's the vertex? It's the highest. The ball started out low, it went up, it reached a maximum, and then it turned around and started going back down. So this, 2.7, and time 0.24 must be the vertex. So we can right away plug in f of t is a times t minus, which number goes there? The 0.24 squared, that's the time number, plus k is 2.70. What's next? And which point do you like? The first one? Okay. It does make a difference which point you plug in. You will get slightly different a values depending on the point that you choose to plug in. So if we choose to plug in the first one, we'll get one a value. If we chose to plug in the last one, we would probably get a slightly different a value. But that's okay, as long as we know which one we're plugging in. All right, so I plug that one in. I get 1.93 equals a times 0 minus 0.24 squared plus 2.70. And what I need to do is get the a all by itself. To get the a all by itself, I think I would subtract the 2.7 on both sides. 1.93 minus 2.7. I get negative 0.77 equals a times, and I think I would grab my calculator and square that. Negative 0.24 squared is 0.0576. So to get the a all by itself, I divide. Minus 0.77 divided by 0.0576. A is negative 13 point, it doesn't say, I'll round it off. Since my data has two decimal places in it, I'll round to two decimal places, I guess. Negative 13.37. Okay, so my equation is f of t is negative 13.37 times t minus 0.24 squared plus 2.70. Questions on that? Questions on how I got that equation? Okay, then it says, part A, plot the data together with your model. All right, so, again, we've done this quite often at this point. We go to Stat. We go to Edit. Clear out L2. Clear out L1. Type in my data. I have 0, 0.06, 0.12, 0.18, 0.24, 0.30, and 0.36. And I move over, I type in this data, 1.93, 2.25, 2.51, 2.69, 2.70, 2.54, and 2.37. I'm going to go to y equals, and I'm going to type in my equation. My equation was negative 13.37 times x minus 0.24 squared plus 2.70. Now, how do I get the calculator to graph both of those for me? Push the graph button. Yeah, I better go zoom 9. I also better make sure, if I go back to y equals, I can see that my stat plot is turned on still. I see that black box there. If that black box isn't turned on, go to second y equals and make sure your plot is turned on. Mine is turned on because we were doing this last time. I haven't changed it since. So I better go zoom number 9 so that the calculator will draw a graph that matches my data. Does that equation match the data? Well, not exactly, but it does give us what I would expect. What I would expect to have happen is it should match very, very well at least 2 points. Which 2 points should it match very, very well for? The two that we used. And we used the vertex, which was this one, and we used the first one, which was that one. So it matches well for those two. Something doesn't look right there. 0.6. Yeah, I guess I typed it in right. And in general, what's going to happen is it should match, since we used this point, it should match fairly well on the left-hand side, and it does, but you can see it doesn't match so well on the right-hand side. And that's because we used this point and we used a point on the left. Had we picked this point over here, then most likely it would match better on the right-hand side and not so well on the left. It does what we expect. That's okay. Part B. Determine the f-intercept. Okay. How do I determine the f-intercept? How do you always determine an intercept? Plug 0 in. If I want the f-intercept, which number do I plug 0 in for? T. So finding the f-intercept means I want t to be 0. So that's f at 0 is negative 13.37 times 0 minus 0.24 squared plus 2.70. I type that in. Minus 13.37 times negative 0.24 squared plus 2.7, and I should get 1.93. Almost. Well, rounding off. Why did I think I should get 1.93?
Because you got the 0 for time, and the stat says for 0 seconds the height is 1.3.
The data says for 0 seconds the height is 1.93, and that was exactly one of the points we had used. If I'd have used a different point, this number should be close to 1.93, but I wouldn't expect it to be exactly the same. But because we used that point 0, 1.93, I expect to get exactly the 1.93 back again. And I did, round it off. Close enough. What does it mean in this situation? So what does time equal 0, height is 1.93 mean? The ball started 1.93 feet high. Correct. Okay, part C. Determine the t-intercepts. Okay, so a similar question to part B, but not exactly the same. How do I find t-intercepts? That means what's going to be 0? F, the height is going to be 0. So that's going to be 0 equals minus 13.37 times t minus 0.24 squared plus 2.70. A little more work this time. How would you solve that equation? Do what? Subtract the 2.7 and then? Divide by the negative 13.37. Excellent. What I see here is I see this parenthesis with the square. When I see that, that tells me I want to get that parenthesis alone and then do square roots. So to solve this equation, I think the best way is to use the square root method. And that's exactly what people were telling me to do. So I would subtract the 2.70. And then divide. So I'm going to take negative 2.7 and divide by negative 13.37. And again, I guess I'll round off to a couple decimal places. If I do, that's 0.2 equals t minus 0.24 squared. And then I would do square root. So I would have plus or minus the square root of 0.2 equals t minus 0.24. Adding over to the other side, t is 0.24 plus or minus square root of 0.2. And again, in a word problem like this, I don't think it makes sense to leave our answer like that. I think it makes more sense to type that into our calculator and get a decimal. So that's what I would do. 0.24 plus the square root of 0.2. I get 0.69. And the other one is t equals 0.24 minus square root of 0.2 minus 0.21. All right, and then we get the same old question. What do they mean in this situation? Junior.
After you have t equals 0.24 plus or minus, yeah, after that.
All I did is I took my calculator, I went 0.24 plus square root of 0.2, and that's how I got the 0.69. And then I did 0.24 minus square root of 0.2. I just wanted to get decimal approximations, just to have an idea of what my values were here. Okay, so what do these numbers mean? What does the t equal 0.69 mean? Well, when t is 0.69, how high in the air is the ball? It's at 0. So what does that mean? Not exactly. Close though. The time is 0.69. When the ball, if height is 0, that means the ball hits the ground. That's exactly right. So what this means is, in 0.69 seconds, the height is 0, so that's when the ball hits the ground. What does the time equal negative 0.21 mean? Nothing. Time can't be negative in this problem. Because time 0 means when we threw the ball. We can't really talk about what happened before we threw the ball. So, the answer is t equals 0.69, h equals 0. That one means a ball hits the ground in 0.69 seconds. T equals negative 0.21 has no meaning. Doesn't make sense in this problem. T can't be negative in this problem. Finally, part D. Part D is the easiest part, I think. Estimate the maximum height of the ball. So according to our equation, when and where is the maximum height? The maximum height is 2.7, and it happened at what time? 0.24 seconds. So in this case, part D, T is 0.24, H is 2.70. Because it's the vertex. And this equation is written exactly in vertex form. There's our X, there's our Y. Questions on that problem? All right, flipping the page. We're going to do the exact same problem again, except we're going to do it a different way. I'm going to want to be able to see the data here at the same time. So this time it says, determine a quadratic model of f of t, where f is the height at t seconds, using the standard form of a quadratic function and creating a 3x3 system of equations. In other words, this time it's saying use f of t is a t squared plus bt plus c. Use that equation. How do I create a 3x3 system of equations?
You pick 3 points.
I picked 3 points. That's exactly right. Which 3 do you want to use? The truth is, it really doesn't matter which 3 you pick. General rule of thumb is simply spread them out. So if I were picking, I would probably pick the first one, the last one, and then one in the middle. Which one in the middle do you like? Which one? This one, the 2.69 one? Okay. So you pick any 3 that you like. Again, good idea, spread them out. Pick one on each end and one in the middle. All right, so what I'm going to do now is I'm going to take these numbers and I'm going to plug them in for t. These are my t numbers. Well, I really like this one because when I plug this one in, I get 0 plus 0 plus c has to equal 1.93. Then I plug in the 0.18. I need 0.18 squared. 0.18 squared, according to my calculator, is 0.0324. So I'm going to have 0.0324a plus, I plug 0.18 in for the t, that's 0.18t, plus c is 2.69. And then finally, I plug in the 0.36, so I got to take 0.36 and square it. That's 0.1296a plus 0.36t plus c is 2.37. Questions on how I got those 3 equations? All right, now how do I solve 3 equations with 3 variables? Especially considering I got all these ugly little decimals involved. Lots of decimals. What would you do? Well, you have two choices. Choice number one is solve it by hand, which I think would be very difficult with all those little decimals. Choice number two is use your calculator. How did we use our calculator to solve these? I got to go to my matrix. Second, get into that matrix. Go over and edit. I need it to be 3 by 4. 3 things down, 1, 2, 3. 4 things across, 1, 2, 3, 4. So 3 by 4 is good. I type in my numbers. My numbers are 0, 0, 1, and 1.93. So I type those in. 0, enter. 0, enter. 1, enter. 1.93. Go down to the second row. Type in those numbers. 0.0, 3, 2, 4. 0.18. 1 and 2.69. And then finally I type in the last row, 0.1296, 0.36, 1, and 2.37. Quit out of that. And then how do I tell my calculator to give me the answer? I go back to that matrix, over to math, down to B, which is RREF, row reduced echelon form. Tell it that I'm using matrix A, and hit enter. All right, so rounding everything to 2 decimal places, I get A is negative 16.67, B is 7.22, and C is 1.93. Just reading off the numbers. The first one is A, second one is B, third one is C. Okay, so that gives me my equation. The equation I want is f of t is minus 16.67 t squared plus 7.22 t plus 1.93. Then it asks us to plot the data together with your model. So I'm going to grab my calculator again. I'm going to type that in. I'm going to see how it looks. What do I expect? Do I expect this one to be better or worse than the first one? Better. Why would you expect this one to be better than the first one? I used 3 points. I used more importantly, I used 1 on each end. So I expect it to fit better on the left and on the right. Well, let's see. Y equals negative 16.67 x squared plus 7.22x plus 1.93. Draw me a picture. I think you would certainly agree that that's better. It's certainly good on the left still, looks much better on the right this time. Is it perfect? Does it hit every data spot exactly? No. Do you expect it to? No, you never expect it to. What you hope is that it comes close to all the data points, and this one does look like it comes quite close to all the data points. So I would say that's a pretty good equation. All right. Part B. Same question we had last time. Determine the f-intercept. How do I determine the f-intercept? Set t equals 0. What do I expect for an answer? Again, I would expect to get exactly 1.93. Oh, you can't see what I'm pointing at. I would expect to get exactly 1.93 since, again, that's one of the data points we used. If I hadn't used 1.93 as one of my data points, I would expect it to be very close to 1.93. But I think you can see here, it is exactly 1.93. Because when I plug in 0, I get 0 plus 1.93. I'm not going to write it down, but once again, what does that mean? At 0 seconds, the height is 1.93, so that was the starting height of the ball. When it was released, it was 1.93 feet high. Part C. Determine the t-intercepts. Once again, how do I determine the t-intercepts? Plug 0 in for f. F equals 0. When f equals 0, I get minus 16.67 t squared plus 7.22 t plus 1.93 is 0. What method would you use to solve that equation? I think your only good choice is to use the quadratic formula. But notice that's different from last time. Last time, because of the way our equation came out, using the vertex form, using the square root method made a lot more sense. Not completing the square, or not completing the square and not the quadratic formula. Quadratic formula is not always the best way. However, for this problem, I think it's absolutely the best way. We're going to have t equals negative b, that's negative 7.22, plus or minus the square root of b squared, that's 7.22, minus 7.22 squared, I meant, b squared, minus 4 times a is negative 16.67, times c is 1.93, and all of that gets divided by 2 times negative 16.67. Okay, a lot of calculator work here. Negative 7.22 plus or minus 7.22 squared minus 4 times negative 16.67 times 1.93. That's 180.8208. But then I have to take the square root of all that stuff. So take the square root of that answer, and I get 13.45. Divided by 2 times negative 16.67 is negative 33.34. So I have negative 7.22 plus or minus 13.45 divided by negative 33.34. Again, I think in this problem it makes a lot of sense to grab my calculator, get decimal approximations. Negative 7.22 plus 13.45 divided by negative 33.34. One answer I get is t is negative 0.19, and the other answer I get is negative 7.22 minus 13.45 divided by negative 33.34 is t equals 0.62. Once again, I think one of those answers is valid and one of them has to be thrown away. Which one do you throw away? The negative. Time can't be negative, so we throw away that one. And once again, what does this one mean? That's when? That's when the ball hits the ground. So that 0.62, I'm not going to write it down again, it means the same thing it did last time. The ball hits the ground in 0.62 seconds. And finally, part D. Estimate the maximum height of the ball. When did it reach this maximum? From this equation, how do you find the maximum? What's it asking you to find? What's another word for the maximum? The vertex. That's exactly right. So given this equation, if I asked you to find the vertex, what would you do? Do what? Plug it into what? T equals, you have a little formula for vertex. Negative b over 2a. It's part of the quadratic formula, and it's the part without the square root stuff. So for part D, I would use the vertex formula. T equals negative b over 2a, which is negative 7.22, divided by 2 times negative 16.67. That's going to be negative 7.22 divided by negative 33.34, same as we had on the bottom of our quadratic formula. T is about 0.22 seconds. So that gives me the time, 0.22. How do I then find the height?
Plug it in for P.
Plug it in for T. So I'm going to take 2.22 and plug it in here. I'm going to have minus 16.67 times 0.22 plus 7.22 times 0.22 plus 1.93. And I get a negative number, which means I did something wrong. Oh, I didn't square my 0.22, did I? Whoops. Go back and fix that. There we go, that's better. So F at 0.22 is 2.71 feet. So we would approximate that the vertex happened, the maximum height happened at time 0.22 seconds, and the maximum height the ball went was 2.71 feet in the air. Questions on that? All right, question number 3. I'm going to let you do question number 3. Question number 3, you do it all over again, all 3 parts over again, except this time the directions are determine a quadratic model using the regression capabilities of your calculator. So how are you going to find that equation? If you've already got the data typed in, which we do, we already typed in the data so we could draw the graph. How do I get my calculator to give me the quadratic equation? Not math. First button I got to hit is statistics, and then over to calc, and then which one are you going to use? Number 5, because we want a quadratic equation. A big mistake people make here is they use number 4. We definitely don't want number 4. Why not? That gives us a line. Does our data look anything like a line? No. So we want number 4. We want quadratic regression. So there's the equation you should have for number 4. I'm sorry, the equation you should have for number 3, right there. Okay, once you have that equation, go ahead and answer all the questions again.